Sweet. We're going to get into adding and subtracting. It's the same thing as what you did with x's and y's and you do with numbers when you add fractions. And that's what's going to happen. We're basically going to be adding fractions, but we're going to be adding fractions with words. Good news is you don't need to know what 4 times 3 is. You just need to know the pictures match. You'll see in a moment what I mean. But we got a few different games. It's not just adding and subtracting. Like this first one. Just asks us to use fundamental identities to simplify the expression. So there's a host of different ways through these problems. When I'm doing any of these, this is not the right way, typically. Especially once we get into 2.2. There's not necessarily a right way, but there sure as hell is wrong answers and wrong work. There's a couple things I could do. I could put those two things together first, 1 over cosine minus cosine, and then bring my cosine in. I could just take this and distribute it in. There's so many different ways that we can tackle a problem like this. So there's not necessarily a right way. You just got to dick around with it until something actually happens. So I'm going to go to I'm just going to go right to it and go, you know what? Screw this. I see a secant. I don't like it. It's looking at me funny. I'm going to change it to 1 over cosine. Now what we could do here is we can make a common denominator. Go over here, you give it a cosine, and then just give it another cosine up top, right? That's just 1, right? I'm adding 1. Same picture over same picture. Yeah. Cosine of x over cosine of x is equal to 1. Just like frowny face over frowny face is equal to 1. It's the same frickin' picture. It's the same thing over the same thing. It frickin' equals 1. So we're not changing anything. That's how you add fractions. All right? That's how you would add a fraction. So we can put it together that way. But maybe you're like, nah, I don't like that. All right, we'll save that for the next problem. Shoot. But that could have worked just fine. Instead, we're like, you know what? Let's just bring this whole bad boy. Let's go. We're going to go put it up into the numerator of both, right? The numerator of both. Remember, if it's just a word, it's over 1. Don't stress. So we set it equal to. And as we bring it in, we got that cosine that's hanging out down below. Oops, let's keep the same color for you. That cosine of x that was there. So the 7 cosine of x, here it comes. Dropping it, so we say 7 times cosine of x. And then we're going to multiply over here by 7 times cosine of x. Let's go. Bang! Cosines go away. You don't have to show all of these steps. Just show me some logical progression as you work through it. So that's just going to leave us with that 7. Minus, and we have cosine times 7 times cosine. Multiplication is commutative. It means you can move anything around you want. So it's going to be minus 7 times cosine of x times cosine of x. That's cosine squared of x. Oh, shoot. Pictures match. Those 7s match. Let's yank that 7 out to the front. And what's it leave us with? 7 times 1 minus cosine squared. 1 minus cosine squared, but that just equals sine squared. We simplified the shit out of that expression. You know what I mean? We went from multiple terms, we go factor, we brought that shit right down. 7 times sine squared of x. Let's go. Alright, that's how the games work. Let's keep running. So this one, we're going to actually add or subtract. Then we'll use our fundamental identities to simplify. We don't really have any choice here. Here's what I mean. Let's rewrite it. Sine of x plus, and we're going to go with the old faithful. We're going to go with the old faithful. Cotangent of x, you're like, absolutely not. That's cosine over sine. So we just changed that. Cool. Let's put it all together. So we get sine of x plus, and then that's cosine times cosine, it's cosine squared, over sine of x. The thing is, we're going to need to create a denominator so we can put that together. Look, they don't match. This picture's a 1, that picture's a sine. I think the one on the left, we're going to need to multiply top and bottom. Just top and bottom. Let's give it a sine, top and bottom. So then the denominators will match for us, right? So now this becomes, now we have sine squared of x over sine of x plus cosine squared of x over sine of x. We have the same denominators. Remember that game? Remember that game? That's what we want to create, huh? To where if you had 1 over 2 plus 3 over 2, you're like, heck yeah, you just 1 plus 3 right over 2 with that common denominator. You don't add those freaking denominators. It's not 2 sine of x. It's just sine of x. So there's that denominator. And we're just left up top with sine squared plus cosine squared of that same variable. Sine squared plus cosine squared, dude, that's just 1. And 1 over sine of x, that's equal to cosecant of x. Again, simplify the crap out of that thing. These are our games. You gotta be able to add, subtract, factor, fractions. You gotta be able to do it all, and you gotta be able to do it with words. And we got these new identities, so that's even on top of the algebra that we'd already have to mess around with. There's a lot of work to be done, a lot of patterns to be seen. I'm good with these because I've seen every frickin' pattern. I've seen all the patterns, so I'm pretty familiar with it. Unless you're just some savant, you're that less than 1/10 of 1%, it might require a little bit of work. All right, so we need to put these two things together and clean it up. Their denominators don't match. All right, their denominators do not match. So we're going to make them match. I'm going to move this little plus sign over just a little bit, put it here. And let's make them match. So I'm just going to multiply this one by whatever the hell that is. 1 minus sine over 1 minus sine. All right, that's just 1. So that's for this denominator. Well, in order to make the other one match, we're going to need to multiply by this one's denominator. 1 plus sine of theta over 1 plus sine of theta. Note that there's no equal sign in an expression. You can't just willy-nilly just multiply by whatever the f you want to. You can only multiply by 1. You can't do shit to it. Don't square anything. You'll be wrong immediately. Don't do that. These are both 1s we're adding. So what has now happened? Now I'm using an equal sign to show my logical progression. Oops, I'll break it up into 2 so we can see it. So we get our 1 plus sine of theta. 1 minus sine of theta over, and then there was that 1 minus sine of theta up top, plus, now down below we have 1 minus times 1 plus. It doesn't matter, multiplication is commutative, so I'm going to write them both the same way. When I say commutative, you can turn it around. 2 times 3 is the same as 3 times 2, and then we'll put our top in there, our 1 plus sine of theta. I would use a parenthesis here a lot of the time because if this was negative, that negative would have to actually travel to both pieces. So careful with that stuff, okay? Careful, careful, careful. There's a minus there. That problem is much, much more dangerous. All right, so now that we have some denominators that match, we can just write this right all over one of them. So what do we have? This 1 plus sine of theta and 1 minus sine of theta. And then up top we got, all right, so there's the 1 minus sine of theta, and now we're adding it to this 1 plus sine of theta. Well, no. Look at that negative sign and that positive sign. Look at that. That's good shit. So what's that? We're left with 1 plus 1? 1 plus 1 is 2, dude. 1 plus 1 is 2. But I think we can go further. You see that difference of squares down there? That a plus b times that a minus b? That equals a squared minus b squared. You remember that shit? Remember that thing? I said I wrote it with y's and x's last time? So this is the same thing as 2 over, and if we play that game, our a is 1, so we square it. 1 squared is 1. And then we say subtract out the other 1 squared, sine squared. Oh shit, 1 minus sine squared, that equals cosine squared. And if you wanted to truly clean it up, it's 2 times secant squared of theta. Look at how clean that turns out from the beginning. They don't always turn out super clean, but that's kind of the game. In the next one, I'll come back with you with the last 2 tricks to be able to complete all of your homework. And then we go into 2-2. It's not really tricks. It's just what's up. Can you do it? So I'll see you soon.